Hello students, I am Manoj Kundare, the Assistant Professor of Electronic Science. Welcome back to our e-learning platform. In previous video, we have seen the details about the passive infrared sensor. The link of the previous video is available in the description box. Please check it. Now, in this video, we are going to see the details about the tilt sensor. Let's see. The sensor which senses angle or inclination of device housing it with respect to the downward force of gravity is known as tilt sensor. It is also known as the tilt switch or tip over switch. That means the sensor which senses angle or inclination of device. For example, a sensor like this is housing with any device with this position, and if this position changes to this position, that means there is the inclination of sensor, hence it produces the output in the form of switch. Okay, and we know that the switch has the two position, on or off position. The sensors are devices that produce an electrical signal that varies with angular movement. These sensors are used to measure slope and tilt within a limited range of motion. Sometimes the tilt sensor are referred as inclinometers. Okay, that means the idea is clear about the sensor is that the tilt sensor senses the angle or inclination of device on which the sensor is placed. Okay, let's see the types of tilt sensor. Tilt sensors are of two kinds: switch based and proportional tilt sensors. The switch based tilt sensor further divided into two types: Mercury tilt switch and ball in case structure switches. The second type, proportional tilt sensor, is divided into three types: electrolytic tilt sensor, MEMS based sensor, and optical tilt sensor. Let's see details about each type one by one. The first one is switch based tilt sensor. Okay, these tilt sensors are functioning as a switch to indicate whether the system is tilted or not. Hence, these sensors has just two states of the outputs and are most basic types of function. The sensors, depending on switching construction, can be further classified into two types: Mercury tilt switch and ball in case structure switches. Let's see once again the switch based tilt sensor. First of all, we have to know the positions of the switch. The switch is operated in only two modes, that means the open switch like this and the closed switch like this. Okay, and these two positions represented by the tilt sensor. Okay, the tilt sensor or the switch based tilt sensor divided into two types: Mercury tilt switch and ball in case structure switches. Let's see the Mercury tilt switch. These are earlier raised tilt switches which uses blob of mercury in glass tube. When the bulb is tilted, mercury rolls to the end and makes electrical connection between two metal contacts. Like here, this is the mercury tilt switch in which there are two metal contacts like this, and here is the mercury block. Okay, now the position of the switch is the open switch because there is no connection here. Okay, but when the switch is tilted like this, then the mercury block comes contact with the two electrodes and makes connection between them. Hence, it operates as the closed switch. This is known as the mercury tilt switch. Here also we can see that there is no connection, hence it acts as open switch, but when the sensor is tilted, then the mercury comes in contact with two electrodes and it acts as the closed switch. I hope you all understand the basic idea about the operation of mercury tilt switch. Now let's see the next type of switch, ball in cage structure switch. These switches are similar to the mercury tilt switches, only difference is that instead of mercury, a metal ball is employed as shown in the diagram. That means it is similar like the mercury tilt switch. Like these switches, the changes is only that instead of mercury there is a ball. Okay, here mercury is used and there is a ball is used like this. Okay, the designing of the ball plays crucial roles as it should not be susceptible to vibrations and shock. Hence, dense solid structure is used instead of hollow shell. That means to avoid vibrations and shock, a dense solid structure ball is used here. Okay, here in this switch, this ball is away from these two electrodes, hence there is no connection between them. In this position, this ball is connected with two electrodes, hence it makes connection between them and it acts as the closed switch. I hope you all understand this simple mechanism. Okay, now let's see the second type of proportional tilt sensor. These sensors, the output is proportional to the degree of tilt. That means in this type of sensors, we've seen that there are only two stages, open switch and closed switch. Okay, but in this type of sensors, there is the output is proportional to the degree of tilt. That means at this position the output is different, at this position, sorry, at this position the output is different, at this position the output is different. Okay, the proportional tilt sensors can be further classified into three types: electrolytic tilt sensor, MEMS based tilt sensor, and optical tilt sensor. Let's see one by one. The first one is electrolytic tilt sensor. In this type, a system of positive negative electrode and electrolyte is used like a dry cell. Okay, here we can see that there are two electrodes, anode and cathode with ground, and the electrolytic is here. Let's see once again. The anode and cathode are immersed in the electrolyte. Now, when the sensor is at rest state, the electrodes are equally merged in the electrolyte. There is no potential generated. That means when the sensor is at rest state like this, then the anode and cathode is equally merged in this electrolyte. Okay, hence there is no potential developed between them. But when the sensor gets tilted, the magnitude of submergence of the electrode varies. This causes change in the potential difference. As shown in the figure, the anode is more submerged in the electrolyte. This will create better conductivity in between anode and ground. That means here we can say that when the sensor get tilted, then the anode is more submerged than cathode in the electrolyte. Okay, hence the electrical potential between anode and the ground is higher, and the cathode and the ground is lower. I hope you all understand the electrolyte tilt sensor. Let's see once again. Here we can see that the sensor is at rest position, and the anode and cathode are equally submerged in the electrolyte. Hence, there is no potential difference between them. But when the sensor gets tilted in this direction, then anode is more submerged than cathode. Hence, the potential difference between anode and ground increases. These are the MEMS tilt sensors. The device, whose inclination is to be measured, can be mounted on a pad containing MEMS sensor. The inclination will be detected by the movement of the object on the sensor. Generally, pressure sensors are employed to convey the inclination information. The third type is optical tilt sensor. These type of devices are used in devices such as digital camera or motion based gaming controllers. Okay, these sensors employs a light source, detector and lenses. Here is light source, detector, and in between them the obstacle is placed. As shown in the figure, the obstruction gets moved when the sensor is tilted, making the detector receive the light from the source and respond accordingly. That means here in rest state we can see that the source emits the light, but due to the obstacle the light does not reach at the detector. But when this sensor gets tilted, then the obstacles moves down, and the source is emitted by the light is emitted by the source is detected by the detector. Okay, that means depending upon the tilt position, the amount of light emitted by the source is detected by the detector. When the total amount of light is detected, then it means that there is no obstacle between them. When the small amount of light detected only, then it means that there is the obstacle. That means depending upon the position of the sensor, the amount of light is sorry, let's see once again. That means depending upon the position of the tilt sensor, the obstacle goes away from the source and detector, and the amount of light will be maximum or minimum depending upon the position of this obstacle. I hope you all understand the working of optical tilt sensor. Now let's see the basic circuit of the tilt sensor. This is the tilt sensor, which is connected with the power supply and the LED. When the device gets power and is in upright position, then the rolling ball settle at the bottom of the sensor to form electrical connection between the two end of terminals of the sensor. That means when the sensor is in upright position, then the ball in the sensor makes connection between the VCC with the LED. Okay, therefore the circuit gets completed and the LED is turned on in this position. Okay, if the circuit gets tilted, that means if the tilt sensor is like that, then the rolling ball doesn't settle at the bottom of the sensor with the electrical conduction path. Hence the circuit becomes open and the LED is turned off. That means when the sensor get tilted, then the rolling ball goes away from this two wires or two connections. Hence there is no connection between them. Hence the LED is turned off. I hope you all understand the working of tilt sensor. Let's see once again. In this position, the rolling ball is settled here. Hence, there is electrical connection between this wire and this wire. Due to this, the circuit gets completed and LED turns on. But when the sensor is tilted like this, then the rolling ball is settled at here. Hence there is no connection between this wire and this wire, like an open switch, like this, the open switch like this. Hence there is no connection between the source and LED. Hence the LED gets turned off. This is the simple circuit of the tilt sensor. I hope you all understand. Let's see the animation here, in which we can see that when this sensor get tilted, there is the connection like this. Okay, here is we can see that when the sensor get tilted, the LED on or off depending upon the position of the sensor. This is the tilt sensor. Okay, I hope you all understand the working of the tilt sensor. Now let's see the advantages of the tilt sensor. First one is Mercury based tilt switch advantage. It is available at low cost and easy to use. It offers very long operating life. It offers low resistance and quiet operation. The advantage of ball type tilt switch is this switch type offers multiple contacts and hence tilt direction can be determined. Moreover, these switches are less toxic compared to the mercury switches. Okay, tilt switches are very small in size. They consume low power for its operation. If properly used, they will not wear out. It is easy to interface with microcontroller and used for various analysis by writing a simple code. These are the advantages of the tilt switches or tilt sensors. Now let's see the disadvantages of tilt sensor. First one is disadvantage of mercury based tilt switch. Mercury is hazardous due to its toxic nature. The disadvantage of ball type tilt switches are, first one is when this tilt switch is subjected to current above its rated specification, arcing may erode its contracts and will becomes less reliable. The vibration of balls from one position to other will create erratic or random signals. They require gravity for its operation, that is, to roll a ball or to move a blob of mercury. Hence, these switches will not work under low gravity, reverse gravity, or zero gravity conditions. Performance of tilt switch in a vehicle which accelerates or decelerates suddenly may also unreliable. The tilt switches deliver erroneous results under significant vibration condition. These are the advantages and disadvantages of tilt sensor. Now let's see the applications of tilt sensor. These sensors are used in many different applications such as in cameras, in video cameras, in aircraft flight controls, in construction equipment, robotic technology, automatic airbags, video game controllers, thermostats, automobile security system, etc. I hope you all understand the working and the types of the tilt sensor. Thank you.